Hello, good day viewers. In this tutorial, I'm going to explain the concept of fundamental theorem of calculus. We have two theorems. Let's start with the first one. Suppose we have a graph of a function f of t. This is f of t, for example, and it happens that this function is continuous under a closed interval a to b. It stated that the area between A to a specific point may be x within the limit. If we want to find the area here, I can confidently call it A. This A right here is nothing but the integral from A to x, where A and B are all constants, but x is unknown, of the function f of t dt. This is equal to capital F of the upper limit x minus capital F of the lower limit a. As simple as that. Then the second theorem is all about the relationship between antiderivative and the derivative itself, which stated that d over dx of this a is the same thing as d over dx of the integral from a down to x of this f of t dt, sorry, this should be t, right? dt equal to f prime of x. You know, we are differentiating every single time. 1, 2, 3, right? 1, 2, 3, 4. The minus f prime, capital F prime of a. But remember that a is constant, therefore f of a must be constant, and derivative of constant is 0. So we end up having only capital F prime of x. But remember from here again, when you integrated lowercase letter f, you arrive at what? Capital letter F. Therefore, if you differentiate capital letter F, you shall obtain small letter f. So therefore, d over dx of the integral from a down to x of the function f of t dt is nothing but lowercase letter f of x. This is 0 because it is constant. Derivative of constant is 0. So this is the relationship, and this is the second theorem. What is this all about? This is nothing but a relationship between derivative and antiderivative. And it is very important because sometimes this function here, f of t, might be very difficult to integrate. So you can integrate this function, take the limit before you differentiate, you must get this. But if this function is not possible to integrate, then you can just skip it to this. So let me show you the whole process, because sometimes you may not get a constant here. It could be another function, and this is x. It could be 2x or x squared. Let me show you the general formula. D over dx of the integral, the lower limit, let me call it a of x, could be any function, and this is b of x of the function f of t dt. This is the same thing as taking that function f of t, then you plug in the upper boundary, that is f of b of x. Then you multiply by the derivative of that upper limit, b prime of x. The minus, take the function again, substitute the lower boundary, that is f of a of x. Then multiply by the derivative of that limit, a of x. So this is the general formula for this. What is the relationship? If the lower limit here is constant, which is a of x, if it is constant, you know that derivative of constant is 0, so the whole of this will be 0. We have only this. And if b of x is x, if b of x is equal to x, simply x, you see this becomes f of x, and derivative of x is 1. So you see we end up having f of x. So in case where this function is very difficult to integrate, you can just skip the integration, just substitute upper limit into the function, multiply by its derivative, subtract, take the lower limit, substitute the lower limit and multiply by its derivative, simplify, and get your final answer. So this is nothing but a relationship between the antiderivative and derivative. Subsequently, we are going to solve many problems under this. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.